Welcome to Spring LIB.
All right, this problem is about TLC, and we've got two products on our TLC plate. And from the start, we've got a product with a labeled 1, which has a lower RF than product 2. And we've got to decide which of these is which, right? So recall what causes something to move up a TLC plate. It's a nonpolar solvent slowly wicking up the TLC plate. The TLC plate itself is very polar. And what this does is it will separate out the contents of your mixture based on polarity. Things that are more polar will be more attracted to the plate and won't travel as far up. Things that are less polar will be more attracted to the nonpolar solvent and will travel further up the plate. So when they ask us which is compound 1 and which is compound 2, what they're asking us is which is more polar or which is less polar, right? Because just from looking at this plate, I can tell you compound 1 is more polar because it didn't travel as far up the plate, and compound 2 is less polar because it traveled further up the plate in the nonpolar solvent. Okay, so now let's look at the structure of compounds I and J, I guess they are. So let me pull those up. Okay, so which of these is more polar? That's really what the question is, right? And which is less polar? Well, the only difference we have here between these two structures is what's on the nitrogen. Compound I has a proton on the nitrogen, and compound J has a T-butyl group on the nitrogen. Now recall that nitrogen-hydrogen bonds are strongly polar, right? And they are, similar to oxygen-hydrogen bonds. They're not quite as polar, but they're fairly polar, right? This is partial negative, and this is partial positive. Now recall that nitrogen-carbon bonds are far less polar, right? They have much more similar electronegativities than nitrogen and hydrogen. Also recall that nitrogen-hydrogen bonds are capable of hydrogen bonding. Nitrogen-hydrogen is an NH is a H bond donor, right? And part of the polarity of the plate, that surface of the plate is covered in silicon dioxide dangling bonds, right? And so there's very polar H bond acceptors on the surface of the plate, right? So anything that's capable of being an H bond donor is going to be extremely attracted to the plate. So I is more polar, and it's also an H bond donor. J is not very polar at all. It's not capable of donating hydrogen bonds. So I'm going to go ahead and say that I is 1. I corresponds to 1. And J corresponds to 2.